Right, and I want to do a little passage on something I've called a harder integral. Of course, whether an integral is hard or not depends on how experienced you are. In this case, I've dubbed it a harder integral because it's not at all obvious how we are going to start working this one out. If you try to do it by parts, you soon get into a mess. So the first thing we do here is use a substitution, x equals tan theta, and then that will give us dx equals 1 plus x squared d theta. That looks a bit hopeful. So when you substitute back into the original integral, the limits will have to change. Pi upon 4 and 0. You can see why, because when x is 1, tan theta has to be pi upon 4, and when x is 0, theta is likewise 0. So, what do we get when we do that? We get log 1 plus tan theta d theta, because the dx has been replaced by 1 plus x squared d theta, and the 1 plus x squareds cancel out. So we got that straight away. However, that by itself doesn't seem to look terribly hopeful. So we'll try another substitution. This time x equals tan pi upon 4 minus theta. And when we differentiate, again, we'll get dx equals 1 plus x squared dx. But this time we'll have a minus here, d theta, because when you differentiate the inside of the argument here, differential of minus theta is minus 1. Also, since x is tan pi upon 4 minus theta, expanding that using the angle formula for tan A plus B, what you will get is tan pi upon 4 minus tan theta, and tan pi upon 4 is 1, so that's 1 minus tan theta over 1 plus tan pi upon 4, which is 1 plus tan pi upon 4 tan theta, which is tan theta. Right. And now when we substitute back into the integral, what are we going to get? So I will equal minus, and again, this time limits are 0 pi upon 4. We'll get log 1 plus 1 minus tan theta over 1 plus tan theta into 1 plus x squared d theta, all divided by 1 plus x squared. And when we simplify that, we can remove the minus sign and reverse the limits. Pi upon 4, 0. The 1 plus x squareds cancel out. And simplifying the bit under the logarithm, what you'll simply get is log of 2 minus log of 1 plus tan theta. d theta. So we've got two expressions for I, one over here, which I'll call 1, and one over here, which is called 2. When you add them together, you'll get 2I, and that'll be pi upon 4, and 0, log 2 d theta, because the log 1 plus tan theta cancels out with its negative when we add them up, and so we're down to this fairly simple integral here now, which is log of 2 times theta, integral of 1 being theta, and between limits pi upon 4 and 0. So that gives us 2I equals log of 2 times pi upon 4. And then dividing through by 2, we come to the final stage. I equals pi over 8 log of 2. And that completes the exercise. Thank you for listening.